Welcome to Vertical City. I'm your host, Lennon Richardson. During each episode, I interview one of the world's top experts in architecture, urban design, engineering, or ecology so that we can better understand and develop solutions for sustainable living. Thank you for listening, and get ready to join us on another groundbreaking and uplifting episode. Ned Daugherty is the founder and CEO of H2O Futures, an environmental consulting, land planning, business development, and landscape architecture firm that specializes in the design and development of biomimicry-focused water systems. Ned has a master's degree in landscape architecture and environmental planning from the University of Arizona. He has lived and worked all over the world, including Japan, Mexico, Brazil, Africa, the Middle East, and America. In this interview, we discuss H2O Futures' proprietary methods for the natural treatment of freshwater and saltwater, including the development of a large saltwater farm in Eritrea, Africa. We also discuss how these processes might affect the development of vertical cities and the future of our water security. Ned is based in San Diego, and I conduct this interview from my home office in Portland, Oregon. For complete show notes, visit verticalcity.org/podcast. All right, Ned, well, welcome to the Vertical City podcast.
Thank you very much.
It's a pleasure to have you. I wanted just to start. We were talking a little bit before the podcast, and you were talking about your holistic approach to design. And I wanted you to just elaborate a little bit on that and give some insight into our listeners as to why you feel this approach is so important.
Certainly. You know, my background as an architect and landscape architect has really been designed. In fact, my career has been designed around the idea that we need to really bring disciplines together and integrate our approaches to problems, because in fact our problems they're not separate. They're all interconnected in some way, and usually very intimately. So as we start to look at issues, we really need to look at the big scale and see how all the interconnections work, and then address those through our own training and curiosity.
Yeah, I definitely agree with that philosophy. I'm curious, in your work, when you're working with water and water systems, how often are you working in isolation, and how often do you get to partner with people from diverse backgrounds?
Well, I think most of the time we are, to some degree, we're always interconnected with others. And, you know, whether it be the client or other professionals, whatever the case may be, whatever the particular challenge is, we are always reaching out, trying to learn from and add to the discussion and the solution that are based not just on our thoughts, but on those of all the people that are on our team, including the client. And that's one thing that's very, very important. We really believe strongly that the client, they're an integral part of the team, and they're the ones that can guide us into what their problems are. So we're very good listeners, and we're very curious.
So I'm wondering if, for example, if you have a new project and the client is going to build some facility and water is going to be a part of the whole compound, how often is it that the water element is dictating any of the other design elements, like the placement of buildings or whatever it may be? Or is this sort of happening as an afterthought in most of the projects where, like, we want to build a building here, so how do we make the water systems work around that?
No, it's very integral. Water is certainly one of the leading elements. You know, in passive design, what we're hearing now, a lot of people are calling about sustainable design, which, by the way, I don't really subscribe to that. I think that we need to go way beyond sustainability. We should be doing enhancement of our environment, not just trying to bring it up to a sustainable level.
That's really interesting. Actually, I've heard several people levying criticism against that word sustainability recently, and that if you're sustainable, that means you're basically stuck. You're staying at one place, and you're not getting better or worse, which certainly can have its benefits, but if you're adding value, then that's going to be a major boon.
Absolutely. So as we look towards, for example, passive design, in other words, looking at our environment and trying to place our buildings or part of our human constructed world, overlaying it onto that, we look at things like solar exposure and soil and topography and all those issues. The water is also a very key element in terms of what's there, what's available in the area as an ambient resource, you might say, and also what the client's needs are. Oftentimes they may have a perception, and oftentimes it's based on what their previous use has been to some quantity of water that they need, whereas, by redesigning systems, we may be able to cut that by some large degree. So it all really depends on, the specifics of the site, the specifics of what the user or the client needs, and then helping the client create problem solving for them to match all the elements of what's existing with what their needs are.
Okay, yeah, that certainly makes a lot of sense to me. So I was taking a look at your website a little bit earlier, and I noticed that you have outlined basically 3 different processes, or you have it isolated for freshwater, and then salt or saline water, and then mixed as well. So I was hoping that we could kind of just go through the processes for each, and you can illuminate the interesting points for the different processes. And starting with freshwater, can you just kind of give a overview of what sort of treatments you're doing and systems you're putting in place for clients?
Sure. We look at water usage first, as I said, and then look at what's available, and that could be water that's used in the building currently, or stormwater, any kind of water, even ambient water in the atmosphere, like fog, things like that, and design systems that can capture that water, then naturally on-site treat it. And I'll talk a little bit about that in a minute.
Okay.
And then reuse it in appropriate ways. So it's all about taking water that's available. And I might say that one of our mantras here is that the problem with water isn't scarcity, it's waste. There's water all around us, but we need to open our eyes and our minds and really understand how the hydrologic cycle works and where water is. I mean, there's water obviously in the atmosphere, there's water in rivers and lakes, and it's even water underneath us in our infrastructure all around us. So if you look at it from that perspective, you'll see that we are really rich with water. The problem is that oftentimes that water it's not thoughtfully used, and it's disposed of in ways that are not appropriate. But we can recycle them and save all that water.
Okay, that's definitely good to hear, because in the media and such, there's always a lot of news about water scarcity, and with the whole bottled water thing that has kind of swept at least through the U.S. Over the last 10 years, and the idea of most of the water that we have access to, especially in cities, is we have this perception of it being not as quality, and there are certainly communities who don't have access to water at times. And there's been the drought in California recently as well. But from what I'm hearing from you, it sounds like there shouldn't ever be a problem if we're using our technology and our resources appropriately, that we shouldn't ever have a lack of water. Is that what I'm getting from you?
Exactly. It's if you're familiar with the term biomimicry,
yeah.
The whole our biosphere 1 is really the hydrologic cycle of the way the water moves through the atmosphere and then through soil and so forth. It's continuously being cleaned. And if we apply biomimicry and look at that system, we can replicate that at a smaller scale on individual projects where we take our stormwater and gray water and black water and run it through clarifiers and tanks with fish and different plants, and so come out resulting in clean water at the end, just like the Earth has been doing for 3.5 billion years.
Makes sense to me. I mean, why try to do something that's you can't really improve upon that efficiency? The nature is inherently efficient.
Right, and we've gotten away from that, and we are really working towards getting back to that system.
All right, so tell me more about the processing of fresh water, because I know that you do a lot of really unique things, and you're using organic materials and things of that nature to clean the water, which I think distinguishes you from a lot of your competitors out there.
Yes, and it's really pretty simple. And we didn't develop this system by any means. It's been being used for decades, probably since the 1950s or 60s. People like John Todd and the living machine concept have been doing this, as I say, for decades. But essentially, you take the influent, the raw water in whatever state it is, whether it's black water or gray water or stormwater, and you put it into a blending tank, and then it goes into other tanks that have plants and animals in them that, through their root zone and the microbes, clean the water somewhat. Then it goes next to a clarifier, and I mean, there are varying degrees of detail here, but essentially you can capture sludge and other microbes and recycle them within the system. But from the clarifier, it drops down into a sand filter, and then goes through a subsurface wetland. And then, depending on what your final use is, you can disinfect it using different things like ultraviolet or various other cleaning agents. And from there, it goes usually into some kind of a holding tank, so it's available. And then you reuse it for irrigation or flushing toilets or groundwater recharge. So it's very cyclical. We can capture and treat, probably reuse about, depending on the system, and each case is a little different, 90 to 95% of the water can be recycled.
That's pretty amazing. That's higher than I would have suspected.
Yeah.
How often are chemicals used in the treatment?
Well, again, it's a case-by-case basis. It depends on really what your ultimate need is.
Mm-hmm.
But so it's really hard to put a number or a percentage to that. But I would say, some degree of cleaning or disinfection are used in maybe, 20, 25% of the time.
Oh, okay.
There's been a real movement recently, which is really great, to use these systems for cleaning water, creating constructed wetlands, and even the relatively new thing is called natural swimming pools.
Huh.
And you can find information about this online. There's some great YouTube videos of this, but essentially it's the same thing. You're just using water. Instead of using chlorine or other chemicals like that, you're using plant material, plants and animals, to treat the water and running it through gravel and sand filters. And yeah, it's very very productive, and there are more and more projects coming online now that are of larger scale too. So.
All right, so these natural swimming pools, this is water that would be obviously safe to swim in, but is it water that's safe to drink?
Yeah, you can. You swim in it, and it passes normal health codes. But this gets into a regulatory question that many, each different agency has its own, and municipality or counties have their own rules on this. But all the normal health regulations apply, obviously, and so even with projects where you're doing gray water and so forth, most municipalities, or several of them, at least the ones I'm aware of, have a requirement that water, after it's being captured and treated, can't be directly accessible. It has to go through a subsurface wetland kind of thing.
Okay.
But the pool water, yes, it's very good and healthy, and you can drink it. It would be like lake water. I don't know that you would want to drink it, but it's okay for human health.
Okay, that makes sense. All right, so you mentioned that and treating the water, you're using a lot of life forms, biota, like plants and fish and stuff like that. So I'm curious, are there any applications where this life that's being used to treat the water is actually then turned around and harvested as a crop or as a food supply or as something else?
Sure. Often that's what's done. After, periodically there will be kind of a harvest of the vegetative matter or the animals, the fish, for productive purposes. That's why we really talk in terms of productive wetlands, because that's what it's all about. It's being productive in terms of cleaning the air, cleaning the water, and then you get this wonderful bonus of being able to use the byproducts, whether it's fish or plants or whatever. The plants can be used for fuel. We can talk about this a little bit more, too, with the saltwater projects, but, we've come up with some pretty creative ways to reuse these byproducts. So lots of opportunities.
And how about like nutrients or minerals? Are these collected and do they have any aftermarket benefits, or can they be sold in some sort of aftermarket?
Well, we haven't done too much of that. With the seawater applications, we do, the end of the process really is salt crystallization. So we can harvest the salt out, but in terms of other nutrients, these processes do clean the fresh water. In fact, they can take out and reduce heavy metals or antibiotics, things like that. There's been recent research done to prove that these are pretty effective at capturing those toxins and other unwanted things.
All right, so how does the saltwater system differ from the freshwater system?
Well, actually, that's an interesting question. It differs, and yet there's some complementary aspects to that. As you recycle fresh water, gradually the water will become slightly more saline, and it can be to a point where you can no longer use it. So our system uses both saline water, whether it's from coastal sites or from inland dry areas that have saline aquifers or other saline elements like that. We can recycle and use the salt water for various things. And as the fresh water is recycled, as it becomes saline, then we can use our halophytes. Halophytes are plants that grow in salt water or saline water. And so as on the freshwater side, as we're recycling fresh water, and eventually after many, many iterations, it becomes slightly saline, we can use that saline water to grow these halophytes.
Okay, these halophytes, is that how it's pronounced?
Halophytes, Halophytes.
All right, so this is a crop that is accustomed to growing in saline water. It likes that environment, right?
Right. And
okay.
What we deal with mostly are what I call terrestrial halophytes. In other words, they grow on land. They grow on land, but they are irrigated with pure, untreated seawater.
That's so interesting.
It's sort of counterintuitive until what I explain to people is think about estuaries.
Okay.
Estuaries are full of plant material.
Yeah.
And they're growing in pure seawater. So what we have done, and by we, I mean our firm, H2O Futures, does this and has been doing this for 40 years, but we didn't really develop this concept. It came out of work done at the University of Arizona, where I worked as a graduate student.
Okay.
Environmental research laboratory there. They really were not just the pioneers, but the actual creators of this whole system. So we've been working with that for years and decades, and try to apply this as much as we possibly can in situations where all the benefits can be reaped.
Okay, so these plants that are growing in the saltwater, then they're harvested, and then what uses do they serve?
As an example, let me just walk you through a project that we did in Africa, on the East African coast. It's in the country of Eritrea.
Okay.
It's below Sudan and north of Djibouti. What we did is we brought in the seawater both directly from the sea through a canal. We cut or dug about 22 kilometers of canals and inland rivers. And most of that was hand labor too, just digging. And the whole project site was about 2,500 acres. And Eritrea is blessed because they have such a large amount of coastal land, and it's desert. So we cut in these canals and then used the water both directly from the sea, and we also had onshore wells. And we took that seawater, again, not desalinated, and we put it into an aquaculture project at the very start of it, at the beginning of the project process, and then used the naturally nutrient-rich effluent from the aquaculture to put onto these terrestrial halophyte crops. And primarily we were growing a crop called Salicornia, and we were interplanted that with mangrove trees.
Wow.
And to my knowledge, it's the first time that mangroves have been done. The work has been done growing Salicornia for a few decades, but the process that we employed was really an integrated system that, again, brought the seawater in. We grew the aquaculture component, and then we grew these crops. And from there, the water drained into a constructed wetland. And on the edge of the wetland, we grew other things like artemia, brine shrimp, and algae, and finally salt through the crystallization ponds. Now, what's really different about this is that none of the water that we brought in and put onto the land and harvested nutrients from, none of that went directly back into the sea. Occasionally you'll hear about, not so much anymore, but we used to hear about these aquaculture farms that would go bankrupt because all of a sudden within a few weeks their whole crop died.
Wow.
And that was because they're recycling their nutrients, putting it back into the sea. In fact, there are some projects that I know of now that have done that recently, and you're recycling pathogens when you do that. So it's not a good thing. So our system, we just put it into this constructed wetland, and it percolates naturally, gets biologically filtered before it returns down into what's called the seawater wedge underneath the shore.
So tell me more about the first step in the aquaculture. What's taking place there?
Well, we grow various seafood products, whether it's shrimp or, again, it depends on the location and the particulars of the project, but it can be shrimp, it can be tilapia, it can be bass, it can be mollusks, it can be sea cucumbers. I mean, you can have a wide variety of seafood that's growing. They each have sort of their own pros and cons in terms of how they grow together, how what the pathogen exposure is, and that sort of thing. But we do it in such a way that we can optimize the health and the productivity. And that the productivity can be either we can grow, for example, shrimp or tilapia, which we were doing in Eritrea.
Okay.
We chose those species because they were there was a market for it. In fact, we were selling shrimp to the EU. We had it certified along with the California to sell in Europe. But the reason we chose tilapia, many people don't realize that tilapia it's a freshwater fish and it's a saltwater fish.
Yeah, that's what I was going to ask.
Yeah, it can cross-adapt. So, and it's a delicious fish, and it grows in very hardy conditions. I mean, the water temperature that we had in some of our ponds got very, very warm, and yet they did extremely well. They thrived. And the other thing that's interesting about tilapia is that we were making leather out of the skins.
Whoa!
And people, it's the leather is actually beautiful leather. We have made several different products from it. It's a multicolored. It's just gorgeous, and it's all part of adding value to the overall project. It's each of the elements that we grew had a byproduct that was able to be used as a resource for something else within the system. So it's a very closed system.
That's great.
Just for example, the California was used. You can eat the tips. It's a wonderful gourmet garnish. And the seed, it's a plant, a bushy plant. It's a succulent, essentially, that grows about up to about a meter, maybe a little less. The tips, the top few inches, you can eat. The seed from it is very high in oil content. So you're able to either use the seed as a flour, or you can cold press the seed to make a wonderful oil that's good for cooking oil or as a biodiesel fuel, biofuel. Wow. Very, very effective biofuel. And the residual, it can also be used, the oil can be used for cosmetics and so forth, but the residual biomass, the straw that was left over from the plant after harvest, we could use as a feed source for the shrimp and tilapia. And also we can use it as a particle board, make particle board or construction material out of it. You can bale it as a straw bale for building construction. And on top of that, it's very effective at carbon sequestration. So you're taking carbon out of the atmosphere, putting it into the soil through the roots. In fact, when we started in Eritrea, the carbon content was just a few percentages. And afterwards, it was up around 18% carbon. So it's enriching the soil tremendously.
Amazing. So is that going to allow you to grow different crops in the future?
Sure. And there are many halophytes that we can grow. There are probably between 100 and 200 that after years of research have been identified as very viable to grow. Even for what I'm talking about now in Eritrea was primarily a commercial crop. But the applications for ornamental landscaping are tremendous also. Okay. Like here in San Diego, we have miles and miles of coastline around the San Diego Bay. And it's currently all the recreation areas are being watered with fresh water. And that's just not necessary. We can use water directly from the sea to grow this wonderful mix of plants, this plant palette that's both readily available and obviously does away with the fresh water need.
So how prevalent are these systems around the world, like this one you've been describing in Eritrea?
They're not. It's unfortunately Eritrea, that project was nationalized and very soon it was dead because it wasn't maintained correctly. There wasn't an understanding of how to actually do it. The project started as a technology transfer project. It was to have lasted 7 years, and after 4.5 years, we were invited to leave because the host government felt they could do a better job or do a job. We had started to export commercially to Europe, and at that point, it's a sad story because many of our friends were nationals, were imprisoned and so forth, haven't been seen again. It's a long, very involved political story that it's beyond the scope of our talk here, but there's a very, very deep story behind it.
Wow, that's really unfortunate. And so in the end, the project was not successful.
I like to speak of it in terms of being a great success. I mean, we employed over 800 people. Now, Eritrea is a country that the annual per capita income is $150.
Wow.
Okay, so so we were employing a large group of people. It was just a really great thing. So I think of it in terms of being a success, but it was terminated.
Okay.
Unfortunately.
Yeah,
we have real aspirations and intentions of going back when things settle down and change. Basically, then we're going to go back and reinvigorate the project and do it.
Yeah, I guess I shouldn't have used the word unsuccessful. It's just that it didn't reach its full potential, I guess. But
exactly.
I imagine that you learned a lot from it. And I think that the whole system it just sounds so amazing to me and so efficient. And you're just taking salt water and then you're using that to produce food crops, the tilapia and the shrimp. They're enriching the water, and then that water goes on to produce additional crops which have multiple uses, which you explained: the oil, the food, and also as a hay for building, and then to go back and feed the tilapia. And then all that water is just running. What did you refer to it as? The seawater shelf, and then back into the sea.
It's called a seawater wedge.
Seawater wedge. Yep. Okay.
Yeah.
And then that's
the water that is seeping under. It's underground, under the shorelines.
Okay. So there are some harmful elements to that water, but I imagine that's being ciphered out before it returns to the sea, just by the process of going through the land. Right. Okay. And then you're also pulling carbon out of the atmosphere and putting it into the soil.
Exactly.
That's amazing. There's so many amazing benefits to that entire system. What are there any significant downfalls? What would be the reasons for not doing it?
Well, we have never found any.
Okay.
In fact, we had some of the foremost ecologists and scientists looking at the project, and like Oak Ridge came out and did some carbon studies, and we found that the water quality was actually much, much better than it was when it came out of the system than it was when it went into the system. And after it had gotten filtered through the constructed wetland as it percolated down into the seawater wedge, that water quality was much, much better than it was in the ocean, in the Red Sea.
Amazing, huh?
But there's also, some of the other benefits, the social benefits too, are equally compelling. We created a women's cooperative. As you may know, Eritrea has been at war with Ethiopia for decades and decades, and because of that, there are a lot of war widows and single mothers. And what we did was we started growing mangrove trees, and to my knowledge, this has never been done either. We would teach these war widows and single mothers how to go out into what was remaining of the natural mangrove forest and harvest seed. Then we taught them how to take that seed and actually do two things. One is that we started a reforestation project, and another was an afforestation project. So the reforestation was able to reforest the coastline where the mangroves had been previously taken away or destroyed. And then on the afforestation side, we were growing hectares of, acres and acres of mangroves that we planted about 8 inches on center the first year. And after the first year, they would grow up to be about 2 meters or so high. And we would take out every other tree to allow more sunlight to get into the remaining trees. And then these women would take the stalks, the plants that were taken out, they would strip the canes of leaves and use those leaves as an animal feed, both in the project system itself for shrimp and tilapia and so forth, but also for goats and camels and cattle. We cooperated with some other NGOs that were there and that were helping farmers grow their cattle. But the problem with that is that with droughts, they were ultimately always dependent on water. So with our system, we have a good protein source that is completely drought-proof. So we took these leaves and gave it to them plus it had salt, which is a good necessary element. So a nice little business for these ladies in the cooperative, and then they would take what remained after they stripped the leaves off. They would take the remaining little stems and branches and weave them and carve them and do things that they could sell them at market as little handicrafts.
Wow.
So we set up a school and so forth, a bunch of other social things, but so there's real. I'm kind of just hitting the highlights right here. There's a lot to it.
Yeah, it sounds like you guys had a lot going on in Eritrea. I'm curious for that whole system. How many resources, or what type of resources, if any, were needed to be brought in from like some external source? For example, I'm thinking of food for the fish, or any sort of equipment.
A good question. In the beginning, we had to bring in the what they call a post-larval, little baby animals to grow. And then we had to bring in feed in the beginning. But after probably the second year, we established a feed mill. And one of the world's most accomplished nutritionist was working with us. And he developed these feed formulations that used things like, as I said, the Salicornia and mangrove and algae that we would collect, and fish bycatch and fly ash and many other things that were indigenous right there in the country, and made these feed formulations that were just spectacular. And we documented, did growth trials and all that. So, and the other very interesting part about that in Eritrea was that because they had been at war, I think for so many years, they were very industrious people and very ingenious. A lot of innovation. They could take any kind of machine part and adapt it, modify it, change it out, and create something else. And so a lot of our pumps and different flow devices and valves and so forth were created basically just from spare things that were found, remnants of battle or other elements like that. In fact, there's a part in the capital city. We were down on the coast, but in the capital city up on the plateaus, the city is called Asmara. There was a recycling center. Basically, it's not what we consider that here in the States, but this was an area of probably 4 or 5 square blocks that people would take found objects, the Eritreans, and they would just, whether it be wood or metal or glass or whatever, and they would just rework these materials into just beautiful things that, were very functional and very useful to their society. And that place is called Metadare, and we used to always like to go there when we'd get into town because you could hear it from blocks away, this basically it was music. It sounded like an orchestra playing of tapping of metal and
Wow.
all different sounds of things. It became like a musical area in town, like a marketplace that was so beautiful. Anyway, I'm digressing.
It sounds
So
it sounds
to
interesting.
answer your question, is very, very productive. Very, the people were ingenious and very, very resourceful.
So where would you like to see these systems around the world? Where are they needed, and where would they function best?
Really, they would function best in the warmer desert climate zones where the desert seashores are.
Okay.
Just because the primary crop that we use, as I said, Salicornia, it really grows best in areas where it's really warm weather. But it doesn't mean it only grows there. It grows in a very high range of latitudes. But it's most productive, in fact, in the hottest areas around the equator and, north and south, maybe 10 or 15 degrees, you can actually get, under the right conditions, you can get 2 crops per year. So, I think, we're looking at sites in the Middle East and the MENA, the Middle East, North Africa region, Australia, anywhere where there's desert seacoast, or as I say, in some instances, it can be applied in interior dryland areas.
Okay, but yeah, I mean, I can think of definitely several places where there's hot environments that are on the coastline. So you have warm weather and you have the seawater, and that seems like the 2 main elements you need.
Yeah, there's been work done in Mexico too, around the Gulf of California.
Interesting. Okay. Well, thank you for sharing all that information about the saltwater systems and everything. That sounds super fascinating to me, and it sounds like something that the world needs to get on board with because there are so many benefits to it. And from asking you, you couldn't really pin any significant downfalls to that processing.
Right. I think that you're right. It really, the idea and the concept, as I said originally, it's sort of counterintuitive, but when people see it and learn more about it, I think they'll realize what the real benefits are. Another issue is, in a global sense too, there are areas of the world where there's conventional farming is done near the seacoast. As that happens, sometimes there's saltwater intrusion as they pull fresh water out of the ground, and we can go into those areas. And I believe there's hundreds of thousands of acres that are they're fallow because there's saline water there, but we can come into these areas and reinvigorate them growing these halophytes.
So what has prevented the adaptation the saltwater system around the world, and specifically in places like Africa?
I think it's mostly because the world doesn't really know it yet. And, there is really no reason. I've done it, we have done it, our team. We've had lots of projects showing that this is completely viable and true. Beyond viable, it's very, very productive. So it's a matter of exposure. And, we're actively looking for sites and project opportunities everywhere.
Okay, excellent. All right, so I want to take a moment just to tie this conversation into the vertical city concept by asking you, how would this system change? Would it become harder or easier to implement something like this if we're building the system around a city that's designed to house 100,000 or 250,000 people, and we're going to construct the city, all the infrastructure, and the water systems at the same time? How does that change everything?
I don't see any reason why it couldn't be a very integral and major part of the vertical cities. It's, when we look at all the other technologies, and some of your guests, of course, with, vertical farming and all those things with hydroponics and new systems that are coming online in every way, there's no reason why it can't be an integral part of of the vertical city and helping people enrich their lives by using things in a more environmentally, ecologically enhancing way.
Okay, good. That's good to hear. I'm also curious if you have any thoughts on the California drought and what might be done to help alleviate the water crisis there.
There's water everywhere. Okay, we need to start thinking about looking all around us. And there's water in our atmosphere, there's water in the soil, there's water in our infrastructure, and of course on our coastlines. So if we look at water in its totality, it's not, scarcity is not the problem, it's waste, and that means wasted opportunities as well as wasting just water itself. Now, we are advocates of really using that water in the most wise way possible, and that means, through the use of systems such as ours and opening our eyes to really look at where water is available and how we can use it and reuse it in the most effective way. So that might mean capturing rainwater, treating it naturally, reusing it, or it might mean, as a project up in British Columbia, University of British Columbia, there's a building there with a gentleman he's an expert in these systems. They did a building on the campus there where they're actually mining the water, the wastewater from underneath the campus as it flows by. They can capture that water, reuse it, treat it, and reuse it in the building. So again, the idea, the notion is that there's water everywhere. We just need to be smart, open our eyes, use our human intelligence, and apply solutions.
Mm-hmm. Well, I personally feel that this is one of the most important issues that we as humanity face. And so I want to ask you, what can our organization, Vertical City, do, and what can our listeners do to support you and to support others who are really trying to create a sustainable future, or an even a more thriving future around water, so that everybody on the planet has access to clean drinking water, and we have access to water for crops and for everything else that we use?
I think probably the main thing or things would be to, I just encourage people to be very curious and don't necessarily take what's being done now, the status quo, as the best possible solution. We should be challenging ourselves to think of new creative ways and reach out. Now with the internet and all the information that's available, there are multitudes of new technologies that are evolving all the time. Mm-hmm. So, I really, I would welcome hearing from anyone that has any ideas about this or sharing the information that we have to help other people, help themselves to new solutions.
Okay, great, Ned. I definitely appreciate that. And we have just a few minutes left here. So if I want to just open this up to you and see if there's anything else, like a project or a concept or idea that you're particularly passionate about that you haven't had an opportunity to discuss yet.
Yeah, most of what I've been talking about, especially with the Eritrea project, is, I would say, commercially based. But the other thing that I'm really, really passionate about is looking at how we can use these water technologies in urban settings. There are, as I mentioned before, in San Diego, for example, there's all this wonderful, rich seawater all around us, and yet we continue to use fresh water for irrigating, and it just doesn't. So that, I guess deploying ornamental halophytes is a real a top issue for me now, trying to educate people that, we can use these resources in maybe different ways, things that people aren't thinking about.
All right, so give me an example of how that might work in San Diego. What would be the benefits to doing so? I guess what I'm asking is, you're using the phrase ornamental, so but I'm assuming that there are benefits beyond just the aesthetics.
Right. Well, yeah, there are. So, for example, I would love to see a demonstration project here that would show people. It would be a facility that would have plants that are grown on seawater. It would have plants that are grown and animals that are grown using recycled fresh water or stormwater. Have this demonstration showcase facility so that people could come and actually touch it and see it and learn more about it and how they can do that. And, it would be it could have a recreational area to it where, like a park setting where there's grasses and shrubs and trees that are growing in some degree of salinity. We didn't really talk about the brackish, or what we call mixed water, but that's where we blend treated fresh water with seawater, and as you adjust the amount of salinity, you broaden the amount of the plant palette that's available to you. So the possibilities are pretty much boundless.
Great. Yeah. Well, I'm certainly rooting for you, and I really have enjoyed this interview. I think I've learned a lot, and I'm sure that our listeners have as well. I definitely appreciate the work you're doing, and just want to thank you again for having you on the show, and to encourage our listeners to do as you said, and just to be curious, to learn more, and let's all work together, and let's create a future where we all know that we have the water that we need to survive and to thrive.
That sounds great, Lennon. Thank you so much. It's been my pleasure. And again, I'm open to helping anybody with any questions they have.
Great. Thanks a lot, Ned.
Okay, thank you.
Thank you for listening to this episode of Vertical City. Learn more about the Vertical City concept and continue the conversation by visiting our website, verticalcity.org. I truly hope that you have enjoyed this episode. If you did, please subscribe to our podcast, leave a review on iTunes, and most importantly, share Vertical City with your friends and colleagues so that together we can create solutions for sustainable living. I'm Lennon Richardson, signing off for the Vertical City team. See you next time.